This is Geometry Unit 10, Lesson 3, more about parallelograms. The properties that we learned in the last lesson about the sides and angles of a parallelogram are very important. We also know something about the diagonals, however. The diagonals of a parallelogram bisect each other. They cut each other in half. So there is a reason that they do this. So let's take a look at the reason and prove why this works. So the diagonals bisect each other. So we are given a parallelogram ABCD, so we know this is a parallelogram. The diagonals AC and BD intersect at point E, and we want to prove that AC and BD bisect each other. Now, how do we know that diagonals bisect each other? Well, to prove that, we would have to prove that AE is equal to EC, because that would divide that into two congruent parts. And we would also have to prove that DE and BE are congruent. So that's what we have to prove they're bisected. Now, when you draw in the diagonals, what does it do to the triangle? Well, or do to the parallelogram, it divides it into triangles. So if we could prove the triangle's congruent, why couldn't we use CPCTC? So that's going to be our plan. We are going to prove a pair of triangles congruent so that we can say by CPCTC that AE is equal to EC and DE is equal to BE. All right, so which triangles do we want to prove? Let's prove AEB and CED, this one and this one. All right, so what we are given is that we have a parallelogram. Let me move this down a little bit so we can see. We have parallelogram ABCD. ABCD with diagonals AC and BD intersect at E. Okay, now we said our goal, this was given, we said our goal was to prove that the triangle up here, AEB, is congruent to CED down here. All right, so let's talk about the diagonals intersecting. Okay, if the diagonals intersect, what do they make? Well, they make angles. This angle and this angle. What kind of angles are those? They are vertical angles. So we can say angle AEB is congruent to angle CED, because intersecting lines form congruent vertical angles. Those are vertical angles. Okay, so that's from the intersection. We have these two angles are now congruent. Okay, now the other thing that we have about this is it's a parallelogram, and we have all kinds of properties of a parallelogram. Well, let's start with the definition of a parallelogram. Well, how's that going to help us? Let's see. We know a parallelogram has both pairs of opposite sides parallel, so that means that AB and CD are parallel. So we know that opposite sides of a parallelogram are parallel, not equal, parallel. Okay, so opposite sides of a parallelogram are parallel. Now, what do parallel lines give us? If these lines are parallel, well, that makes the diagonals transversals, doesn't it? So what kind of angles would we have there? Well, we actually have two different pairs. We have pairs of alternate interior angles. So let's pick one. Let's say we had ABE, this angle right here. We have angle ABE would be congruent to angle, in the other triangle, ABE would be congruent to angle CDE, which would be this angle down here. These would be alternate interior angles. All right, if lines are parallel, alternate interior angles are congruent. Okay, so if lines are parallel, alternate interior angles are congruent. Okay, so we have two angles in the triangle. So all we need now is a side. We can either get angle side angle or angle angle side. Well, let's see. If we have angle and angle here, we would have to get this side and this side congruent, but we don't have any way of doing that. But if we get this side and this side congruent, we could use angle, angle, side. All right, well, where are these sides in the parallelogram? They're opposite sides. Well, what else do we know about parallelogram sides? They're congruent. So we would know that this side and this side are congruent if it's a parallelogram. So we could say that AB is congruent to CD because opposite sides of a parallelogram are congruent. So they're parallel, but they're also congruent. So now, are these triangles congruent? Yes, they are. We just decided that it's going to be angle, angle, side. So that's triangle ABE. ABE is congruent to triangle CDE. And we just proved that by angle, angle, side. Now, we could also on this, we could have proved this by angle, side, angle, by proving the other pair of alternate interior angles here. This angle BAE and ECD. These two angles could be proved, and we could prove angle, side, angle there too as well. But either way is fine. This one works just fine. All right, so now the triangles are congruent. So what we wanted to do was get AE and CE congruent. So is now AE congruent to CE? Yes, it is, because that's by CPCTC. By CPCTC, and also isn't DE and BE congruent by CPCTC? All right, the triangles are congruent, so all the corresponding parts are congruent. Corresponding parts are congruent, triangles are congruent. Now, since this is divided into two congruent parts, that means that those diagonals, AC and BD, bisect each other. Now, the reason for that is the definition of a bisector. A bisector divides a segment into two congruent segments. And since this has been bisected into two congruent segments, it must have been bisected. So there we go. So we have just proved that the diagonals of a parallelogram bisect each other. So now we can use that as a theorem. Now we have parallelogram easy, EASY. EASY has diagonals intersecting at R. Find the lengths of the diagonals. All right, so we know the diagonals bisect each other in a parallelogram. Diagonals bisect each other. So that means that the two diagonals cut each other in half. So that means that ER is going to be equal to RS, and YR is going to be equal to AR. So this is equal to this, and this is equal to this. Now, setting up our equation for each one, ER is X, and RS is Y minus 2. YR is 2Y minus 8, and AR is X plus 4. Okay, now since this is two variables, we need two equations. This is already solved for X, so why don't we substitute this in over here? 2Y minus 8 is equal to Y minus 2 plus 4. I just plugged in for X right there. Combine your terms. 2Y minus 8 equals Y plus 2. Move your Y over here, so that gives me Y minus 8 is equal to 2. Add the 8, so Y is equal to 10. So now we know that Y is 10. That means X is going to be 10 minus 2, which is 8. So X is 8 and Y is 10. So now that we know that, we can find the lengths of the diagonals. All right, let's fill in the values that we have. We know ER is X, so that makes that 8. And if we did this correctly, this piece should also be 8. Let's see. Y is 10, 10 minus 2 is 8. Yep, that works. So that means that ES, the whole diagonal ES, will be 16. For the other diagonal, we have 2y minus 8. All right, y is 10, so 2 times 10 is 20 minus 8 would be 12. And hopefully we did this correctly. 8 plus 4 is also 12, that works. So that means that AY, the other diagonal, is going to be 12 plus 12, which is 24. So our last theorem about the properties of parallelogram, besides the opposite sides equal, opposite sides parallel, opposite angles congruent, opposite angles are congruent, and consecutive angles are supplementary, we also know that the diagonals bisect each other. And we can use that theorem to help us solve different problems about parallelograms.